Now, part C asks us to implement Thumper, a generator function that takes a positive integer k and a digit m, and it yields all k-digit worms with digits that are all less than or equal to m, and it yields these results in increasing order. Also, assume the number 0 has 0 digits. Okay, cool. So we have our standard if-else kind of structure. So we know it's going to be base case, recursive case. Now our base case. So if k is equal to 1, that means we're yielding all 1-digit worms with digits that are at most m. So that means we want to yield all the digits starting from 1 to ... all the way up to m. And the reason why we don't start from 0 is because it says that in the problem that we want to assume the number 0 has 0 digits. So the way you yield all of these numbers in order is with a yield from. So we're going to yield from, and then we want some iterable that contains all of these values. And the way you can get that is using the range function. And you want to start at 1 and then end at m inclusive, but since range has like the end as exclusive by default, you're going to go up until m plus 1. Because that's going to include m, but not include m plus 1. So now for our recursive case. So now let's think about how can we split up this problem so that we can solve it with recursion. Well, a way to think about it is you can think of k-digit worms as essentially k minus 1-digit worms with another digit tacked on to the end, right? So if we somehow had all of the k minus 1-digit worms, you could get to all of the k-digit worms just by adding some digit to the end. So conveniently, we can assume that we have a way to get all of the k minus 1-digit worms because that's essentially our recursive leap of faith, right? So if we had some way to get all of the k minus 1-digit worms, which we do, we can call Thumper on k minus 1 and m, then we're just going to have to yield all of the k-digit worms by essentially tweaking these worms. So for example, if we had like k equals 4 and k minus 1 equals 3, and for example our k minus 1 worm was like something like 1, 2, 3, well, the way you get to a k-digit worm, so a 4-digit worm from this, is to essentially add on this other digit, and this other digit has two options. It can either be a 2 or it could be a 4, right? Because these are the two valid worms that come from 1, 2, 3. So it looks like we actually have this structure right here. So this is going to return essentially our 1, 2, 3, 2 worm, and this, oh, not yellow, let's do blue. Okay, and this is going to return our 1, 2, 3, 4 worm. So why do we have these if statements then? Well, it turns out there are a couple constraints. So we can't always subtract 1 from the digit. For example, what if our number, or what if our worm was 1 or 3, 2, 1, 0? Well, if our last digit is a 0, you wouldn't be able to append like another digit that's 1 minus 0, so you wouldn't be able to add like -1 and call that a worm. So this is only valid if the last digit of w is greater than 0. Similarly, if you were to have a worm that looks like 1, or looks like 7, 8, 9, you wouldn't be able to make this next digit like a 10 or like a 0 even, because that isn't a valid worm. So we can only add one, we can only tack on a digit that is 1 more than the last digit if the last digit is at most 9. Now, what about our constraint in the other direction? When can we not add a digit that's 1 greater than the previous digit? Like when can we not yield that worm? Well, we remember from our original problem that we have this constraint that all the digits in the worm have to be less than or equal to m. So if m was 4, and you had some 3-digit worm that looks like 1, or that looks like 2, 3, 4, we know that you can't have a worm that has a digit 5, so adding on this digit 5 would be not allowed. So this is kind of the second constraint where we want our last digit to be less than m. So we want our last digit, w mod 10, to be less than m. In that case, we can safely yield this worm that tacks on a number that's, or a digit that's greater than the last digit. Cool, so those were all the blanks. Now just for completion, let's fill these in. So A was, I'll switch back to black now. A was yield from range 1 to m plus 1. B was thumper called on k minus 1 m. Okay, 3 is fill in the blank, so let's make sure that what we wrote is actually an option. So w mod 10 is greater than 0. We have that here. And then we wrote w mod 10 is less than m, which is right here. Cool. So that's all for this problem, and I'll see you in the next part.